This talk presents some additional result on semi-global stabilization of nonlinear system by n-dimensional sample data out of the feedback. This is a joint work with my PhD student, Ji-Wei Sun. Here is outline of my talk. A brief review on the recent advance is given, especially on SGAS result versus semi-global practical stabilization result by sample data out of the feedback. And then I will give you a motivation about why we focus on semi-global asymptotic stabilization rather than global asymptotic stabilization. Why the condition GALES, global asymptotic local exponential stabilizability, is key in achieving SGAS result by sample data feedback. The problem statement, assumption, and lemma are then given. The first main result of this talk is on SGAS by n-dimensional continuous time out of the feedback. Then, based on this result, together with the zero-order hold technique, the ZOH, we can prove that the semi-global asymptotic stabilization by n-dimensional sample data out of the feedback controller can also be achieved. An example is given to demonstrate this theoretical finding. My talk ends with some concluding remark. So let me give you a quick review about what is the recent advance. In recent paper of 2020, we studied the following basic question for multi-input, multi-output nonlinear system 1 and 2, when it is semi-globally asymptotic stabilizable by either sample data state or by sample data out of the feedback, and under what kind of conditions. And the semi-global stabilization problem can be formulated formally by the following definition 1. Essentially, the idea is you can find a sample data type controller 3, which is discrete time controller, to semi-globally stabilize the continuous time control plant. In the following sense, the closed loop system, which is hybrid in nature, is locally asymptotically stable. At the same time, its domain of extraction can be absolutely large. It's a compact set. So the main result of the 2020,000 paper can be summarized by the following two theorems. Theorem 2 essentially says that the multi-input nonlinear system, if is GALES, globally asymptotically, locally exponentially stabilizable, then it is must semi-globally asymptotically stabilizable by sample data state feedback. In the output feedback case, it can be further proved that if the MIMO nonlinear system is uniform observable and the GALES, it is SGAS by sample data out of the feedback. So here is some motivations why we focus our attention on the SGAS rather than the GAS. Consider this two-dimensional system, and this system is GES, globally exponentially stabilizable by this nonlinear feedback, and this system, it can be proven that it will never be GAS by the sample data feedback controller when I'm using the zero-order hold. Indeed, the closed loop system, which is a hybrid by nature, always has a finite escape time from certain induced condition, no matter how fast of a sampling time t is. And as a result, this example indicated that in the context of the sample data out of the sample data feedback, seeking SGAS is more suitable than seeking GAS. The second example illustrates why it is critical and crucial in this work to require the global asymptotic local exponential stabilizability condition. So this is a very simple non-affine system. It can be proven that it is not GALES by any smooth feedback, yet it is globally asymptotic stabilizable. Indeed, it is a finite time stabilizable by U equal to minus X 1/5 order, the holder continuous controller. And then using the zero order hold technique, it results in the sample data controller over here. And the corresponding hybrid closed loop system can be proven that always, starting from no matter how small of the initial condition, you always get a periodic solution, Therefore, the closed loop system is neither LAS, locally asymptotic stable, nor semi-global asymptotic stable, no matter how fast or how small of the sampling T is. So this indicate, in order to achieve semi-global asymptotic stabilization, LES is crucial. So the main result of our 2020,000 paper is based on the following strategy. One, you need to build a high gain observer. Two, your estimated state must be saturated in order to avoid the finite escape time. And finally, in order to deal with the non-affine dynamic system, you have to use the dynamic extension technique. As a result, the dynamic extension technique resulted in a sample data output feedback controller of dimension PM plus MM minus 1. So for the M input, P output system, the dimension is very, very high, much higher than N dimensional. And in the single input, single output case, this number reduced to M minus 1. So this raises a very interesting question. And this is the question we want to provide a partial answer in this talk. Under what kind of conditions we can find an N-dimensional sample, SGAS sample data out of the feedback controller for nonlinear system. So in this talk, we focus our attention on a class of the single input, single output nonlinear system of the form 9, which is in a very general form. And HXU is any higher order than the linear order term. The linearization part is in a general form. So AC is in the observability canonical form. And then we show that under the following two conditions, SGAS can be achieved by n-dimensional output feedback. The condition, assumption 4 is the first condition, is same global asymptotic local exponential stabilizability condition. And the condition 2 essentially give a structural condition under which SGAS can be achieved by n-dimensional sample data output feedback. This condition is sort of the Lipschitz condition, but the Lipschitz constant is replaced by nonlinear function. So this condition is rather general, include a very general class of a non-affine nonlinear system. And also I want to mention some preliminary result. Because we assume this nonlinear system is globally asymptotic, locally exponentially stabilizable, and this condition can be characterized if and only if by the invariance. So actually, if system is GALES, it means we can find the approval function satisfying these two inequality. This is not only sufficient condition, but also necessary. And we're also using the saturation function, which is a standard property of the definition, and it is satisfying the property tool. We are going to use this property later. And lemma 6, lemma 7 are pretty standard. Lemma 6 is a global Lipschitz condition on the compact set. Lemma 7 is some estimation inequality we are going to use later. So the first main result of this talk is the ThA19. Under the two condition, assumption 4 and 5, then the single input, single output non-affine system 9 and 10 is SGS by an n-dimensional continuous time output feedback controller. For instance, you can construct a controller like 14 and 15. So I'm not going to spend too much time talking about how to design this controller, and the details can be found in the textbook, and so it is semi-global asymptotic analysis. I will rather focus on the main result of this talk, which is the ThA19. So under the exactly same condition, together with the zero order hold, we can prove that the same SISO non-affine system is semi-globally asymptotic stabilizable by n-dimensional sample data out of the feedback controller, as long as the sampling period T is not too big. So the semi-global asymptotic stabilization result by sample data out of the feedback can be proved in the following steps. To step 1, using the converse theorem on GALES, you can find the V function, and then you need to construct a level set, and then you make sure that your initial condition, which lies in the arbitrary large compact set, is contained in this level set. And then we using the zero order hold together with the continuous time out of the feedback controller to get a sample data out of the feedback controller. This is n-dimensional controller, okay? So it's the same dimension as the system state. And then based on this controller, we can show that how to get a discrete time controller. And the key is we need to construct a subtly approved function. VCX is coming from the stabilizability, and VEX using log function is coming from the aerodynamic. And using this V, we construct a level set omega. And then using some subtle estimation and analysis, we can prove that on the level set with some estimations, eventually the hybrid closed loop system satisfying the following property: V theta tk plus 1 is always less than low V theta tk if the sampling t is less than beta over gamma square root. And then in that way, we prove that the local asymptotic stability of the hybrid closed loop system. Moreover, its domain of attraction is arbitrarily large. So it's over here. That's how we prove the semi-global result. So let me give you some quick example. So this is a two-dimensional example. You can show that the system is uniform observable and is also globally asymptotically locally exponentially stabilizable. And therefore, by my previous paper, three-dimensional controller exists. But now, based on our new result, the two-dimensional continuous time controller 35 or the sample data controller 36 can be constructed. The simulation also demonstrated our theoretical finding. So in conclusion, this is what I present in my 3-minute summary. So we provide a partial answer to this question: when is a nonlinear affine system? A non-affine system is SGS by n-dimensional sample data output feedback controller. And a future work will be focused on how to design n-dimensional controller for the MIMO nonlinear system instead of the SISO nonlinear system. And that's it for my talk. Thank you for your attention. Let me stop here.